But let's look at unimodal distributions, distributions that just have one peak. These are quite common, and they come in three varieties. There are symmetric distributions where the peak is in the middle. For example, if you took everybody's heights in the world and made some kind of bar graph or histogram, they'd be approximately symmetric. There's left skewed data distributions. If you look at this picture on the right, almost all of the data is on the right-hand side of it. It almost looks like a mini symmetric distribution on the right, but there's some small, very infrequent data on the left that's kind of dragging the entire distribution a little bit to the left. An example of a left skewed distribution might be something like the ages at which people die from natural causes. So some very young people die from natural causes, but most people die from natural causes much older in life. A right skewed distribution is the opposite. Most of the data is on the left, but there's some extreme data further to the right that's dragging the distribution overall towards the right. Salaries might fit a right skewed distribution. Most might hover around $50,000 or $60,000 a year, but then there are some who have a handful of folks with very, very large salaries, and their frequency is very small, but they drag the distribution overall to the right. In later sections, we're going to analyze how skew might affect the way we measure the center of a distribution. Let's look a little bit closer at a couple of examples. We'll start with a symmetric distribution. Suppose I toss a coin 8 times. Suppose it's a fair coin. And I want to record the number of heads that comes up across all 8 tosses. Now suppose I do those 8 tosses 100 times. What we have in this chart is the relative frequency, the percentage of those 100 trials that resulted in 0 heads, 1 head, 2 heads, and so on. Let's make a graph of this and take a look and see what this data distribution looks like. So as usual, to generate a graph, we highlight the data. There are no totals or anything here, so I'll highlight all of the data. Go over to Insert, Recommended Charts, and I'll pick this bar graph. This is a nice symmetric distribution. Notice it's got a single peak, and the peak is in the middle at 4 heads out of 8 tosses. That makes sense when you think about it. Okay, I'll let you in on a secret. I didn't really do this 100 times. Rather, I know the probabilities that are involved, and what are really here are the probabilities of getting 0 heads, 1 head, 2 head, and so on. We'll talk about probabilities more in Chapter 3. Let's look at one more example, this time of some skewed data. What we're looking at here is from a US government report using census data to describe the distribution of household income in 2019. Now, the very large peaks on the right may suggest to you that this actually isn't skewed, but maybe multimodal. Here's the reason why we can't draw that conclusion. If you look really closely, and I'm going to zoom in just a little bit more here, there's a little gray box over these 2 bars at the end. And if you look at the notes, what's going on here is that the bin sizes are much larger. So each of these bin sizes are for household incomes in $5,000 ranges, $15,000 to $20,000, $20,000 to $25,000. And you notice that over here, we've got a single peak here right in the middle, and then it starts to decrease, and you start to see the effect of this right skew. What's happening with these 2 bars is that the bin sizes for this second to last bar is 50,000. Those are incomes from 200 to 250,000. And then here is the last one is 250,000 and over. But if we kept slicing by incomes of 5,000, we would see this decrease continue, and we would see what would look like an honest right skewed distribution. Next, before we close this video, I want you to notice something. There's the median and the mean. that are flagged here. The median income is 68,703 and the mean income is 98,088. Notice not only are they different, but the mean is to the right of the median. That is not an accident. The next thing we want to start talking about is measures of where the center of the data is. Mean and median are two examples of measures of where the center is. Before we do that, we've got to take a little side quest to talk about something about summation notation. In the next video, we'll start section 2.2 on exactly that topic.